All right, this is exam 2, fall 2023, chapters 3 and 4. First, we have this projectile motion problem. So this is a problem where the ball starts at ground level and it goes up and it comes back down again. It tell you that it's at an angle of 60 degrees that has an initial speed of 12 meters per second. And I want to know the speed of the ball at the top of the trajectory. And I want to know what is the range of the ball, what is x, I don't know what is v at the top, and then what is the speed of the ball at t equal 1.7 seconds. So first of all, in order to find the speed of the ball at the top of the trajectory, well, that's actually pretty easy. So I can, for part A, the speed of the ball at the top is just this, that the velocity in the y direction at the top has gone to 0, and so the velocity at the top of the trajectory is just equal to the x component of the initial velocity. So I have v at the top is equal to v naught x component, which is equal to v naught times the cosine of theta. So that's equal to 12 cosine of 60, which is equal to 6.0 meters per second. And then for the second part, I want to know what is the range. There's several steps to this. First, I need to find the time. I know that at the top of the trajectory, that the velocity in the y direction at the top is equal to 0. There is no velocity in the y direction at the top. It goes to 0. So I can further say that that's equal to v naught y plus ay times t, and that's going to be t top. So I get 0 equals v naught y. Well, let's do that up here. I'm going to do my v naught y is equal to v naught sine of theta. It's equal to 12 sine of 60, which is equal to 10.4. Let's do 10 meters per second. And then I've already found that v naught x is equal to 6 meters per second. So I'm going to write that. That's what I did right here. I'll need that in just a bit. All right, so 0 is equal to v naught y. That's equal to 10 meters per second minus 10 meters per second squared times t top, which is t top. So if I solve that for t top, I find that t top is equal to 1.0 seconds. That means at the top of the trajectory I have 1.0 seconds. That means down here that I have 2.0 seconds that has elapsed. So the total time is equal to 2 times t top, or 2 times 1, or 2.0 seconds. Now to find the horizontal range, I say x is equal to vx times t. I've already found vx. It's right here. It's equal to my v naught x, so it's equal to 6 meters per second times 2.0 seconds, or 12 meters. So that's that answer. And then what is the speed at t equal 1.7? So let's just make a point here that that's going to be, well, right about here. And I'm going to have one component of that that is 6.0 meters per second. That's actually what I found in this first part, which is also the velocity at the top. It's also the initial velocity in the x direction. So I need to know what is the magnitude of this vector first. So Vy at that time is equal to V naught y plus Ayt. That's going to be V naught y is 10 meters per second plus negative 10 meters per second squared times 1.7 seconds. 10 minus 17, negative 7 meters per second, which negative, that should tell me that I'm doing okay because I know that that velocity is going to be negative. It is in the downward direction because I've passed up the 1 second mark. I'm at 1.7 seconds. So now to find the velocity at that time, or the speed rather, I say the square root of vx squared plus vy squared. It's going to be the square root of what's vx? 6 meters per second squared plus negative 7 squared. And the negative is going to go away because it's squared. So it's the square root of 36 plus 49. I get 9.2. All right. All right, so this block is on an inclined plane. It's being pulled up a rope with a force of 120 newtons. What is the normal force? Assuming no friction, what is the acceleration? Then, if I assume kinetic friction, what is the acceleration? So I have a couple problems. First, I just need to find the normal force. Well, first, I'm just going to draw my forces. I have a normal force, Fn, and then I have the weight right there. Then I can also draw my coordinate system. Looks like that. Just redraw that force vector. Now I can redraw this coordinates, or I need to know this angle right here. That angle is 90 minus 30 or 60 degrees. Let's redraw that coordinate system, and I'm going to resolve my x and y components. This is step number 2, or step number 3 really. This is going to be FW cosine of 60. This is FW cosine of 60. And then this is my 120 newtons, that's F. I'm going to go ahead and FW, is equal to M times G, that's 5 times 10 or 50 newtons. So I'm going to go ahead and put these values in. So this is 25 newtons, and then this is sine of 60 times 50, or 43 newtons. So I'll go ahead and put those values in. Well, so I've already answered that really. If I want to know the normal force acting on the block, I say the sum of the forces in the y direction is equal to 0. That will always be the case for the inclined plane because the block isn't leaving the inclined plane. And I can say then that Fn minus Fw sine 60 is equal to 0, or Fn is equal to 43 newtons. That is the normal force. For part B, assuming, for part B, sorry, for part B, assuming no friction is acting, then what is the acceleration on the block? Well, it's going to do the sum of the forces in the x direction is equal to max. So in this case, there is acceleration of the block. I'm assuming up the inclined plane because that's the direction that the force is pulling. We'll see 120 newtons minus 25 newtons is equal to 5 kilograms, 5.0 actually, times AX, and I solve that for AX, and I get a value for AX that's 120, that's 95 divided by 5, which is what, 19 meters per second squared. So that is my acceleration up the inclined plane. And then for part C, I need to know, well, what if there's friction? So in this case, there will be friction that will be acting down the inclined plane. That's going to be my kinetic friction. And then I can add that right here. So there are 2 steps here. The first thing I need to know is just what is the magnitude of that kinetic friction? I know it's mu k times the normal force. I already know the normal force. I know mu k is 43, so it's going to be 0.1 times 43 newtons, which is 4.3 newtons. That should be 1.10. That is the value of my kinetic friction. So now I can do the same thing I did in part B, where I do the sum of the forces in the x direction equals max. That is going to be 25 plus 4.3 minus 120 is equal to mass times acceleration in the x direction. I just realized, by the way, that I made a mistake over here, so let me just correct that this actually should have been negative 120, and that should have been positive 25, which would have given me a negative 19. That means that I had an acceleration up the inclined plane, which is minus 19 meters per second squared. Sorry about that. Now, go back here. I didn't make that mistake here, so I have 29.3 minus 120. That's minus 91 is equal to the mass, which is 5 times AX. So AX is equal to 18 meters per second, negative 18 meters per second squared. All right, so that's the answer to that one. And then for number 3, I just have these 2 vectors. I want to know what is the sum a plus b. Let's just draw them so I'll get some idea of what I've got. So I've got 24 at 60 degrees above the x-axis, and then 30 degrees below the 32 newtons at 30 degrees below the negative x-axis. So it's going to look sort of like that. So I know that my resultant vector is going to be a vector here that's gone in that direction. So if it looks drastically different, like I know that the direction has to be in the second quadrant, for example, then I know I've got an issue. So I can come back to my picture and try to figure out what that is. So first of all, I just want to find my x components, ax, bx, ay, by. AX is 24 cosine of 60. Uh, BX is negative 32 cosine of 30. Let me show you. I'm going to draw another coordinate system. The vector B is right there, so it has a negative x component and a negative y component. Um, so this is 28 newtons, and this is 12 newtons. By is going to be negative 32, that should be negative 28, negative 32 sine of 30. That's going to be 16 newtons. And then this is going to be positive 24 sine of 60. And that's 21 newtons. Then I add, this is negative 16, I add these values, the AX plus BX equals 12 minus 28, which is negative 16. And then I do the same for AY plus BY plus 21 minus 16, that's 5 newtons. So I have this vector that has an x component that is 16 units, a y component that is 5 units, and so it's going to look something like that, which notice that looks a lot like what I drew here. Um, let's find the magnitude of that. I'll call that r, and the magnitude of r is the square root of 16 squared plus 5 squared. Drop that negative because it's going to be squared anyway. I get 16 or 17 newtons, or I would have taken 16.8 newtons if you're keeping 3 sig figs, but it looks like I just had 2 sig figs up here. So 17 is really the correct answer. All right, so 17 newtons. And then if I want to know the angle, I'm going to report this angle. So phi is the inverse tan of the y over the x, that's 5 over 16. At 17 degrees. 17 newtons at 17 degrees. So that is the angle phi, or this is from the negative x. That would have been what I was looking for. Or you could have said 360, or excuse me, 180 degrees minus 17 degrees is, what's that, 163 degrees from the plus x. Actually, I would have preferred here, not from, but above the negative x, because we can report uh, angles above or below the x-axis, but when you report it in this way, it's assumed that it's measured counterclockwise. That is, that would be 163 degrees. Okay, tough free response. A lot of vectors there. You launch a projectile in the horizontal direction off a platform that's 125 meters tall, so y is negative 125. Projectile has an initial speed, that's all in the x direction, of 30 meters per second. I want to know the speed of the projectile when it reaches ground level. So what is the speed when it reaches this point? Now remember, it's going to have an x component that will be 30 meters per second. And then I also want to know what is the y component. So I need to know what is Vy. First thing I need to do is just find the time. So to find the time, I say that y is equal to V naught y t plus 1/2 ayt squared. That's negative 125. V naught y is 0 because it's all horizontal initially, so that just goes away, becomes 0. So it's equal to 1/2 of negative 10 meters per second squared times t squared. That's 125 divided by 5 is, by negative 5, it's 25 equals t squared. So t is equal to 5 seconds. That's how long it takes to get to this point. Then I want to know what is the velocity in the y direction. That's going to be v naught y plus ay times t. 0 minus 10 times 5. That's negative 50. So I have two vectors down here. I have one that's 30 meters per second and another that's 50 meters per second. So to find the sum of those, I say the square root of 30 squared plus 50 squared. And that's going to be 58.3 meters per second. Okay. Cannonball is fired horizontally off a 10 meters per second from a cliff that's 125 meters tall. How far from the cliff does it land? So very similar problem. In fact, you could have used some of your work from the previous problem because it's the same height of 125 meters. That is that the y displacement is negative 125. I know from the previous problem that the time right here is equal to 5 seconds. 5.0 seconds. And I want to know what is this distance, x. So x is equal to vx times t. This is 10 meters per second. That's the initial velocity, but that's also the velocity in the x direction. So it's going to be 10 meters per second times 5 seconds, or 50 meters. Which of these plots represents the y component of the velocity for an object launched from ground at an angle and returns to the y position? So that's this situation. The y component of the velocity is initially big and positive, it gets smaller, it goes to 0, and then it gets small and negative, and then bigger and negative. So it starts out big and positive, gets smaller, goes to 0, small and negative, big and negative. So that's the right answer. One ball is dropped, another ball is fired. So I have one ball that just goes straight down, and then another ball that goes off to the side like that. Which of these statements is true? The fired ball will have a greater speed at the bottom. Yes, because it has a component that's in this direction and a component that's in this direction, whereas this one only has a component that's identical to this one, but only in the y direction. So that one is right. The drop ball will take less time to reach the bottom. No, they take the same time. The fired ball has a greater acceleration. Um, so no, both of them have an acceleration in the y direction that is equal to negative 10. And actually both of them have an acceleration in the x direction that is equal to 0. So no, they actually have the same acceleration. And the acceleration of the dropped ball is 0. That could be correct, except it does have a y acceleration. So no, that's not right. So it looks like for number 4, that's the answer. Projectile is launched from the ground at an angle of 30 degrees. Which point does it have its least speed? So that would be at this point. We've already addressed this. It only has a velocity in that direction. That's that. All right, here we go. We have these. All right, so here we have a battleship that fires simultaneously at 2 enemy submarines. This is straight from our concept test, by the way. I want to know which submarine gets hit first. The answer is B, and the reason that I know that the furthest submarine gets hit first is because the height of the trajectory is lower than the height of the trajectory here. So this one, the one that hits A, just has a lot of hang time, whereas this one has a lesser hang time. Vector A is 6 units in the plus y direction, and vector B is 3 units in the negative y direction. This is A, this is positive B. I want to know what is the result of A minus 2B. Well, I need to double the size of B and negate it. So that means that B minus 2B is going to be, that's minus 1B, that's minus 2B. So A plus 2B is going to be, actually, let's draw it tip to tail. is going to look like that. This is negative 2b. So that's going to be 6 units in the positive y direction. Vector A has a magnitude of 3 units and is at an angle of 30 degrees above the negative x-axis. 30 degrees, 3 units. What is the y component? Okay, so the y component, I know, first of all, has to be positive, so it can't be those. And so it's going to be 3 sine of 30, which is positive 1.5, so 8 is D. Um, Here, what is A plus 2B? So again, we're doing this twice the vector, so that's B, and then that's 2B. So the sum is going to look like that, which is the same as that one. So that's the answer. Vector magnitude of 3 cannot be added to a vector of magnitude 4, so that the magnitude of the resultant is what? Well, we have two extremes. I could have 3 and the 4 gives me one that's 7 units long, or I could have a 4 and then minus the 3, which gives me a vector that's 1 unit long. So it has to be between 1 and 7. So the answer is 0. It's not in between those max and min sums, vector sums. Object moving to the left across the surface, so in the negative direction. The object experiences a frictional force. Which of these statements accurately describes its motion? So an object is moving with a velocity to the left, and it experiences a frictional force. That's a kinetic frictional force. The object is accelerating. Yes, because it's going to be slowing down due to the frictional force. The object has a negative velocity. Yes, the object has a negative acceleration. No, in order to be slowing down, the acceleration is in the positive direction, so it's not 3. The object will eventually stop. Yes, because he has this force acting upon him. So it's going to be 1, 2, and 3. Oh, 1, 2, and 4, excuse me. Let's see. Um, person is in an elevator. The person is holding a 10-kilogram mass. They exert a force. That's the tension in the rope, actually. I'll just call it Ft. Which of these statements is true? Also recognize that there is a force weight pulling down. If the elevator accelerates downward, the mass of the block decreases. Okay, no, the mass doesn't change depending on its acceleration. If the elevator accelerates upward, F is bigger than 100 newtons. So yeah, that is true. I could do the sum of the forces. That's going to be F minus Fw equals m times a positive acceleration. So F would equal to Fw plus ma. So yeah, F then would be bigger than Fw. The elevator is stationary, F equals 0. No, if it's stationary, F would equal to 100 newtons, which is just the weight of the block. So not 3. And if it's accelerating downward at minus 10 meters per second squared, then F equals 0. Let's redo this here. So I have sum of the forces equals F minus Fw equals ma. So what happens if the acceleration is negative 10? Then I get F is equal to Fw plus m times negative 10. That is, well, I have 10 kilograms, so that's 100 newtons. That would be 10 minus 100 newtons would be equal to 0. So yeah, that is correct. So what do I have there? 2 and 4. D. Mass of this block is 20 kilograms. What is the acceleration of the block down the inclined plane? Then assume no friction. All right, so let's draw our forces. The normal force. You don't really have to do all this, but let's just do it just for fun. Fw, and then we'll draw those Fn. Oh, by the way, this angle is 30 degrees, so then I have Fw cosine of 30 and Fw sine of 30. All right. About the simplest inclined plane problem that we can have to find the acceleration, let's say the sum of the forces in the x direction. That's Fw cosine 30. That's the only force in the x direction is equal to mass times acceleration. So the acceleration is equal to mg cosine 30 over m. Those m's cancel, and I'm just left with g cosine of 30. which is equal to 8.7 meters per second squared, E. All right, block of mass 10 kilograms that's uh, at rest on a horizontal surface. Let's see, looks like I was intending 2 sig figs here, so I'm going to assume that we have some decimal points here. I might go back and fix that. What's that, 14? Um, let's just draw our forces. So I have a weight here. My force weight is equal to 100 newtons. I also have a normal force, and I have a kinetic friction that's going to be acting in this way. And then I have this force. I'm going to now draw it and resolve all the force vectors. So this is 100 newtons. This is my normal force, Fn. This is 20 sine of 30. And this is 20 cosine of 30. And then this is Fk. All right, so first of all, I need to figure out what is the normal force. There are a few steps here you have to take. Figure out what the normal force is, then I can figure out what the kinetic frictional force is, and then I can determine the acceleration. So step A, find the normal force. I say that the sum of the forces in the y is 20 sine of 30. Actually, I'll just go ahead and let's see here. 20 sine of 30, this is equal to 10. So 10 plus Fn minus 100 equals to 0. So that means that Fn is equal to 100 minus 10, or 90 newtons. That is my normal force. Part B, find Fk. I know that Fk is equal to mu k times the normal force. That is 0.1 times 90, or 9 newtons, 9.0 newtons. That is Fk. Now for part C, find the acceleration. I do the sum of the forces in the x. It's 20 cosine of 30 minus Fk equals ma. 17 minus 9 equals the mass, which is 10, times the acceleration. 17 minus 9, that's 8 divided by 10. Should be 0.80. All right. Here I want you to tell me which equations are correct or not correct. Uh, the block does experience a frictional force. Let's see, I can draw my normal force there. My frictional force, it's going down the inclined plane, so that's right. I'm going to go and resolve my force weight. This is going to be Fw sine of 60, and then this is Fw cosine of 60. And I know that it's accelerating. Just to remind me, I'm going to write that arrow there. Fn is equal to Fw sine 60. Look, that's the sum of the forces in the y direction. Yes, so that's correct. Fk equals mu k Fw sine of 60. Since this is equal to Fn, then I can substitute that in there for Fn. And so yes, that is correct, that Fk is equal to mu k times the normal force. Then Fw cosine 60 minus Fk equals max. That's this minus this equals max. Yeah, that's just the sum of the forces in the x direction equals max. So that's correct. And Fk equals Fw cosine 60. Okay, that's not correct because it is accelerating. So I could say that the sum of the forces in the x direction is Fw cosine 60 minus Fk equals max. But ax is not equal to 0, so that's not the answer. So 1, 2, and 3 are the right answers, but you may have put E in it. If you did, the reason that it's not E is because this is not equal to 0. That is very clearly accelerating. The block is accelerating down the inclined plane. So the answer is D. You run out of gas, you and your friends have to push your car out of the road. Which of these statements best explain why it's difficult? It has a lot of mass or a lot of inertia. Not because it has a big weight, that's a vertical force, so it doesn't affect how you push it, nor a large frictional force. It doesn't actually have a very large frictional force, and I'm confident that you and your friends are strong. 5 kilogram object accelerates downward at 8 meters per second squared. What is the air resistance? So this is the forces that are acting on it. I'm just going to call this lowercase f. It's a resistive force, air resistance, like friction, sort of. The sum of the forces in the y direction will be F minus Fw equals MAY. F then will equal to MAY plus Fw. MAY is the 5 kilograms. Be careful of my signs here. Minus 8 meters per second squared plus Fw, which is 5 times 10 or 50 newtons. So that's minus 40 plus 50, which is equal to 10. You exert a 20 Newton force on a rope attached to a 2 kilogram block. The coefficient of kinetic friction between the block and the floor is 0.1. What is the acceleration of the block? So let's draw our forces. I have a normal force here. I have my tension force here. I've already labeled it there. Here I have the weight of that object, and then I'm going to have a kinetic frictional force in this direction. First thing I do is I need to know what this kinetic frictional force is, which means I need to know the normal force. Easy, right? Because there are no angles here. So my normal force is equal to my weight, which is equal to 20 newtons. This is 20 newtons. So that's my normal force. That means that Fk, which is mu k times Fn, is equal to 2 newtons. So this is 2 newtons. That means that the sum of the forces in the x direction is 20 minus 2, or 18, and that's equal to max. So 18 is equal to 2 times ax, so ax equals 9 meters per second squared. All right, here I have the elevator problem. It's ascending 3 meters per second squared. This is 10 kilograms. I have a tension here and a weight here. And I want to know the tension in the rope. Sum of the forces in the y direction. That's Ft minus Fw equals MAY. Ft then is equal to Fw plus MAY. That's going to be 100 newtons, that's the weight, plus 10 times 3 meters per second squared is 30, 130 newtons. So C is the right answer. Okay, so here, this is like our rocket problem that we did in class. 10 kilogram stone is initially at rest. It's accelerated by a force of 15 newtons. After t equals 6 seconds, what is the stone's velocity? So first, I need, oh, and then the mass is 10 kilograms. First, I find A, that's F divided by M, which is 1.5 meters per second squared, and then the velocity is V equals 0 plus A times T. Excuse me, this is V naught, but it's equal to 0. So that's equal to 0 plus 1.5 times T, which is 6 seconds. That's 9 meters per second. All right, tough exam, y'all. There was a lot of stuff that we've seen, but still, like I said, a tough exam.